Hello everyone. Today I am here with you all with fifth chapter of class ninth maths, that is Introduction to Euclid's Geometry. This chapter is more of your theoretical part. It tells us about the history of geometry. So let's see it. Geometry comes from the Greek word, that is your geo and matron. The meaning of the word geo is your earth and the meaning of matron is your measure. That simply means it is because of the requirement of measuring the length, the word geometry has been originated. If we see the ancient civilization, that is of your Greece, Egypt, India or China, so we'll come to know that they were even aware about the concepts of geometry. They were even using the concepts of geometry, although it was not in a systematic form, but still they were using it. So let's see some of the example which proves it. The word Sulabh Sutra, it was the manuals of geometric constructions which were probably originated from construction of different kinds and shapes. So it was there in the ancient India. Similarly, Sri Yantra is one of the complex example of geometric construction which consists of 9 interwoven isosceles triangles arranged in such a way that they produce 43 subsidiary triangles. So all these examples shows geometry was being developed and applied everywhere in the earth, in the world. So not only in India, in the Egypt also, in your Greece also, in China also, the concepts of geometry was being used also and was developed also. Although it was not in a systematic form, they were not proving it. Means because of the reasoning, by reasoning, they were not proving the statements, but still they were using the concepts of geometry. So geometry developed by Egyptians mainly consist of the statements of results. Simply they were using the statements of results. They were not proving it. They were not using the reasoning behind it. But the Greece, the emphasis was on reasoning behind why certain construction works. So the emphasis of the Greece people were about the reasoning, why this construction is working, why this is applicable. So they were emphasizing on the reasoning. And the Greek mathematician Thales is credited with giving the first known proof of the statement that circle is bisected by its diameter. He was the first mathematician who proved that diameter is bisecting the circle. That means circle is bisected by its diameter. And his students only, we know about Pythagoras. He has proved so many theorems he has proved. So he was one of the student of your Greek mathematician Thales only. And one more student, that was Euclid, who was a teacher of mathematics at Alexandria in Egypt. He collected all known work and arranged it in his famous treatise called Elements. So what he did is, whatsoever the work was done in the field of your geometry, he collected all that work and he introduced it in the famous treatise, that is your Elements. He named it as Element. And he divided this element into 13 chapters, and each chapter was termed as your book. So your Euclid, he introduced method of proving geometrical results by deductive logical reasoning. By reasoning, he introduced the concept of your proving the geometrical results. And that's the reason the previously proved the results. The geometry of plane figures is known as your Euclidean geometry. And about this only we will be learning in this chapter. Now let's see some of the definitions given by Euclid. According to Euclid, a solid has shape, size, position and can be moved from one place to another. That simply means a solid, a three-dimensional figure which we say it nowadays. It is having the shape, it is having the size and it is having the position, and we can move it from one place to another place. Its boundaries are called surfaces. Suppose I am going to say that this is a solid, right? It is a cube. So its boundaries, the boundaries of this solid, it is your surfaces. These are the surfaces, as we say that in a cube there are 6 surfaces are there. So similarly, according to Euclid, a solid is having shape, size and position. It is having the shape even, it is having the size even, and it is having your position even, and we can move it from one place to another. If we are going to see its boundaries are your surfaces. These are the boundaries. Over here we can see these are the boundaries over here. It is having the 6 boundaries, and these boundaries are known as your surfaces. They separate one part of the space from another, and these surfaces are separating one part of the space from the another and are said to have no thickness. That simply means it is having length, it is having width, but it is not having any thickness. It is having only 2 dimensions. It is not having the third dimension. These boundaries of surfaces are curves or straight lines. If we are going to see the boundaries of these surfaces, so either it will be a curve or it will be a straight line. So we can see over here, these are your straight lines. The edges or the boundaries are your straight lines, and these lines end in points. And if now from here, these are your lines, the boundaries of this surface is the line, and the line is ending at your points. The ending point of these lines are your points. So he began his exposition by listing 23 definitions in book 1 of elements. So he has defined 23 definitions in the first chapter. That means your book 1 of your elements. So what he described is that from three-dimensional figure, which is a solid, its boundaries are your surfaces. Now surface is a two-dimensional figure. Its boundaries are your lines, which is your one-dimensional figure. That means it is having only length, it is not having width. Surface is having length and width, it is not having thickness. And your solids are having all the three, that is solid, your length even, width even, and height even. Now ending point of this line is your points, which is having no dimensions. So from 3 dimension to 2 dimension to 1 dimension and ending at your dot, that is a point with no dimensions. So this is how he described about your solids, surfaces, lines, and your point. So let's see how he defined it. A point is that which has no part. No part means it is having no length, it is having no width, it is having no height. So point is that which has no part. A line is breadthless length. That means it is having length, but it is not having its width. Length only, the one dimension it is having, that is your length. No other dimension it is having. And the point is having no dimensions. The ends of a line are points. Wheresoever your lines are ending, these are known as your points. The straight line is a line which lies evenly with the points on itself. That means on the line, if we are going to see the line, if we will take points evenly, then a line will be formed. That simply means a straight line is a line which lies evenly with the points on itself. So if points are lying on this line, so it is means points are kept close to each other, then it is going to form a line. A surface is that which has length and width only. So surface is the thing which is having length and which is having the width. It is not having the thickness. That means 2 dimensions it is having. The edges of a surface are lines. That means the edges or the boundaries of a surface, it is your line. A plane surface is a surface which lies evenly with the straight line on itself. That means if we are going to draw the straight lines on the surface, we are going to get a surface. So line was where points were evenly distributed, and surface is the one which is having the lines on it evenly distributed. So this is how he represented, he defined a point, a line, a surface, and a solid. Point is the one which is having no dimension, no length, no width, no thickness. Line is the one which is having only one dimension, that is your length, and the ending point of the line is your points. Surface is the one which is having 2 dimensions, length and width, and its boundaries are your lines. And the solid is the one which is having all the 3 dimensions. This is all are the definitions which were given by your Euclid. But in these definitions, even there were so many parts were there, so many terms were there, which is to be further defined. Because see, part, what is part? No one knows. What is length? What is width? What is your point? All these were the terms which were to be further defined. But if we are going to define these points further, these terms further, then again there will be so many terms will be coming which is to be defined. That's the reason these terms were taken undefined only. Directly we were using these terms like point, like line, your surfaces, all these we were taking it directly, because while we were defining all these terms, there were so many terms which we will be using which is to be defined. So multiple terms would be there which are need to be defined. So that's the reason, although Euclid has defined your point, even he has defined the line also, he has defined the plane also, but these definitions are not accepted by the mathematicians, and that's the reason these terms are now taken as undefined. These terms we are taking it as undefined. We know what your point is, what is line, what is your surface, all this. It is not to be defined because whatsoever the definitions Euclid has given, it is not accepted by the mathematicians. Now let's understand some of the terms like statement, axioms, theorems, postulates, what all these are. Statement. A sentence which can be judged either true or false is called a statement. That means if we are going to take a sentence and by seeing that only, by reading it only, we can come to know, we can judge whether it will be true or false, then these type of sentences are known as your statements. Then comes your axioms, the basic facts which are taken for granted without any proof and used throughout mathematics are called axioms. That means the basic facts which we know it is true, which we are not proving it, although we are not proving these facts, but we know that these are true, such type of facts, and these facts we are using in mathematics. That means for proving other things, we are using these sentences, these evidences, these proofs we are using. If these are the cases, then these facts are known as your axioms. So these are the basic facts which we are taking for granted. Means by default we are assuming it that they will be true. We are not proving it and we are using these concepts, these facts in the mathematics. These type of facts are known as your axioms. These are chosen on the basis of our intuition. That means our intuition says that it will be true. There is no other condition which will prove it to be wrong. Means in each and every condition it is true only, and what appears to be self-evident. It is self-evident that that condition, that evidence, that fact will be your true only. These facts are known as your axioms. We make sure that axioms are consistent. So what consistent it? If there is no other axiom or no other statement which can prove this axiom or other axiom to be false, in that case these type of axioms are known as your consistent axiom. That means there is no other statement, there is no other axiom which can prove it to be wrong. These type of axioms are known as your consistent axioms. Inconsistent. If we can use one axiom to show that another axiom is not true, that means if using any one axiom we can prove that another axiom is not true, in that case they are your said to be inconsistent. If we cannot prove by any of the axiom that another axiom is not true, that means another axiom is not false, in that case they will be your consistent. But if using any of the axiom we can show or we can prove that another axiom is not true, is false, then they are known to be your inconsistent. Now let's see what postulate is. Postulate are the basic facts which are taken for granted without any proof, used specifically in geometry, are called postulates. Like in axioms we were saying the basic facts which we are taking for granted without proving it, that these will be true in every condition. It's our intuition or it's your self-evident. It is for any type of mathematical evidence, fact could be. But if these facts are specifically for your geometry only, then these evidences, these facts are your postulates. That means basic facts which we are taking for granted without any proof. We are not proving it, we are not proving it, we are taking it for granted that these statements, these evidences, these facts will be true in each and every condition, but it is specifically for geometry. In that case it is known as your postulate. And if it is general for any of the mathematical statement, in that case it will be your axiom, but if it is for geometry, then it will be your known as postulate. Then comes your theorem. Theorem is a statement that can be proved using previously proved your results, and some axioms is known as your theorem. If there is any statement which we can prove using your another axioms which we have already taken for granted, if using any of the axioms or any of the proved results, if we are going to prove any of the statement, then these type of statements are known as your theorem. Here these statements are going to be proved. We are proving it using any of the axiom, using any of the previously proved results. We are proving the statement. If we are proving it, then it is known as your theorem. In the case of axioms, in the case of postulates, we are taking it for granted. We were not proving it. But in the case of theorem, we are proving these statements. Then your conjecture. It is a statement which we believe or claim is true based on our mathematical understanding. Whatsoever we understand about mathematics, according to that we are believing or we are claiming that the statement will be true. Although it is not compulsory that it will be true. It may be true or it may be false also, but as per our understanding, we are believing or we are claiming it to be true. And experience, that is our mathematical intuition. By our mathematical intuition, by our mathematical understanding or our experience, we are believing it, we are claiming it to be true, but its truth or falsity is yet to be established, may turn out to be true or false. That means it is not compulsory that it will be true. It is not even compulsory that it will be false. We have to check it. We have to establish the fact that whether it is true or false, but we are believing it as per our understanding of the mathematics that it will be true. We are believing it, we are claiming it. If this is the statement, then we say it to be conjecture. Now let's understand some of the Euclid's axioms. That means statements which we have taken for granted to be true. We have not proved it. Simply we have taken it to be true, that are known as your axioms. So some of the Euclid's axioms we'll be discussing right now. The first Euclid axiom says that the things which are equal to the same thing are equal to one another. That simply means if we are going to see it geometrically, suppose there is a triangle, there is a rectangle and there is a square. If the area of the triangle is equivalent to the area of the rectangle and the area of the rectangle is equivalent to the area of the square, that means area of the triangle is also equivalent to the area of the rectangle and area of the square is also equivalent to the area of the rectangle. In that case, area of triangle will also be equivalent to the area of the square, because both the area of this and both the area of this are equivalent to the same thing, that is area of your rectangle. In that case, area of this triangle and area of this square will also be equal. Things which are equal to the same thing. This area is equal to the same thing, that means area of this, that means they both will be equivalent to one another. Another way we can say that if A is equivalent to B and B is equivalent to C, or you can say value of A is equivalent to value of B and value of C is also equivalent to value of B. Both A and C are equivalent to your B. In that case, A will also be equivalent to C. The second axiom says that if equals are added to equals, the wholes are equal. That means if A is equivalent to B, right? These two are equal, A is equivalent to B. If equals are added to equals, if we are going to add C in A and if we are going to add C in B also, then also they will be equal, because A was equivalent to B. A was already equivalent to B. Now we have added C, which is equal in both the two. In A also and in B also we have added C. In that case, result A plus C will also be equivalent to your B plus C. If equals are added to equals, wholes are also equal. The third is if equals are subtracted from equals, the remainders are equal. That simply means, again we can take this example. If A is equivalent to B, both of them are equal, and if we are going to subtract same thing, that is C, from both of them, then also their result will be equal, their remainder will be equal in that case also, because A was equivalent to B and we have subtracted the same thing C from both of them, so your result will be equal. Then comes your fourth, things which coincide with one another are equal to one another. Suppose I am going to say that there is a line is there AB, it is coinciding the line CD, and if your another line is even there, that is your EF. If AB and CD are coinciding and if CD and EF are coinciding, then AB will even coincide your EF. That simply means things which coincide with one another are equal to one another if they are coinciding each other. If this is coinciding this, then they both will be equal. No need of taking the third one, because they are saying that things which coincide with one another are equal to one another. That simply means if there are two lines are there, which is overlapping each other, which is coinciding each other, in that case both of them will be equal. This is not required. They both will be equal. Fifth says the whole is greater than the part. We have all these things we know now. We already know all these things, but initially they were the axioms which was written by your Euclid. So if we are going to take a circle, this is the whole. If I am talking about this part from it, so obviously we can say the whole will be greater than your part. Or we can say if we are talking about the whole A, it will be greater than your A upon 2. This is your part of it. A by 2 is the part of A. So A will be greater than your part, that is your A by 2. Or if I am going to say, if I can write A equivalent to B plus C. There are two things, because this is not equal, this is the part, right? That means if A is equivalent to B plus C, then we can say that A will be greater than your B, because we are adding C, then only B plus C is becoming equivalent to your A. That simply means A will be greater than B also, and A will be greater than C also, because while we are adding B and C, then the value of B plus C is becoming equivalent to your A. That simply means A is greater than your B and A is greater than your C. So whole is greater than the part. The sixth is things which are double of the same thing are equal to one another. Say if it is written things which are double of the same thing. Suppose I am saying A is equivalent to double of B. A is equivalent to double of B and C is also equivalent to double of B. A is equivalent to twice of B and C is also equivalent to your twice of B. Things which are double of the same thing. This is equivalent to double of the same thing, then A will be equivalent to C. In that case, your A and C both are going to be equal. Things which are halves of the same things are equal to one another. If I am going to say that A is equivalent to half of your B and C is also equivalent to half of the B only. Half of B is common for both the two. A was equivalent to half of B and C is even equivalent to half of B. In that case, A will be equivalent to C. So things which are halves of the same things are equal to one another. So these are the statements which were not proved, which were simply the statement by default only, by by simply our assumption only. We have taken these statements to be true, and that's the reason they are known as axioms. And we can see that these all are your true. We cannot prove using any of the axiom another axiom to be false. That means all are your consistent type of axioms. Now let's understand incidence properties of points and lines. Let L be a line and P be a point. If P is an element of L, that means if P lies on L, or P is incident on L, or L contains P, or L passes through P. That means if there is a line L and there is a point P, which is element of L. Element of L, that means P lies on L. That means P point is lying on the line L, or P is incident on L, or P is incident on this line L. Or we can say that L contains your P. On this line L, P is contained by your line L, or we can say L passes through point P, or we can say that line L is passing through point P. If any of these conditions are there, then we say that it is your P point is incident on your line L. So what incidence axiom says, a line contains infinitely many points. If we are talking about a line, so infinitely many points are there on this line. So a line contains infinitely many points. Through a given point, there passes infinitely many lines. If we are talking about a point, so through this point, infinitely many lines can pass through this point. From one point, any given one point, so many, infinitely many lines are there which can pass through this point. Given 2 points A and B, there is one and only one line that contains both the points. If there are 2 points are there, this is your point A and this is your point B. So there is only one line will be there which will pass through both of them. Infinitely many lines you can pass through any of the given point. But if we are going to talk about both the 2 points, so there will be only one line which will be common for both the 2 points, that will pass through both the 2 points. Two lines may or may not have common point. It is even possible that the two lines are having a common point. These are intersecting lines, so this point is common for both of them. But if the lines are parallel, in that case there will not be any common point between these two lines. Whatsoever the length, we can extend it up to both the lines. The distance between both the lines will always remain same. It is not going to decrease in any of the two sides. That means they won't have any common point on these two lines. So now what collinear points are? If there are three or more points are said to be collinear if there is a line which contains all of them. So if there are this three points or more than 3 points are there, and if we can draw a line which will have all these points together, means in a single straight line, if we are having all these points, then these points are said to be collinear. Concurrent lines. Three or more lines are said to be concurrent if there is a point which lies in all of them. So if this line, this line, this line, this line, if three or more than three lines are there which is having a common point, all these lines are having this point as the common point, then these lines are said to be your concurrent lines. Three or more lines are said to be concurrent if there is a point which lies on all of them. So this is the point which is lying on all of them, which is common for all these lines. Betweenness. A point C is said to lie between the points A and B if A, B, C are collinear. If A, B, C, these 3 points will be collinear, then we will say that C is lying between your A and B. If they are not collinear, suppose I am saying this is A and this is B and this is C, so they are not collinear, because if I am going to draw a line, I cannot join all the 3 points. So if they are not collinear, in that case C will not lie between A and B. C is not lying between your A and B. So C is said to be lie between your points A and B if A, B, C are collinear. If they will be collinear, then we will say that C is lying between your A and B. Along with that, one more condition should be fulfilled, that sum of AC plus CB should be equivalent to your AB. If sum of AC plus CB is equivalent to your AB, then we will say that they are your collinear points, or they are C is lying between your A and B. Because see, this is even the condition. If over here I am saying this is your 2 centimeter, this is your 4 centimeter, and this is your say 3 centimeter. So sum of AC plus BC is not equivalent to your AB. That's the reason C is not lying on your AB. So if C will lie between your A and B, in that case 2 conditions should be fulfilled. Your first is your ABC should be your collinear points. Another is sum of AC plus CB should be equivalent to your AB. Now let's understand some of the Euclid's postulates. That means statements related to geometry which we have taken for granted that it is true, which we have not proved it. It is not proven, but we have taken for granted that these statements are true related to geometry. The first postulate is a straight line may be drawn from one point to another point. That means if there are 2 points are there, then we can draw a line which will pass from one point to another point. That means a line can be drawn from any 2 given points. If there are any 2 points given to us, then we can draw a line which will pass through both of them. Although we can draw only one line which will be passing through both of them, we cannot draw more than one line which will be passing through both of them together. We can draw from one point, we can draw multiple lines, infinite lines we can draw from one point. From this point even we can draw multiple or infinite lines, but the line which will pass through both of them will be unique. Only one line we can pass through both of them. The second is A terminated line can be produced indefinitely. That means if it is a terminating line, that means it is your line segment. In today's time we say it to be line segment. That means whose length we can measure. So if we are going to take a terminating line, then we can just produce it in both the direction. That means a line segment can be converted into a line. So a terminating line, that means a line segment whose length is fixed, whose endpoints are there, can be produced indefinitely. In both the direction we can produce it indefinitely. The third is a circle can be drawn with any center and any radius. We know that suppose I am going to take this as the center. So from this center we can draw a circle with 2 centimeter radius also, with 3 centimeter radius also, 4 centimeter radius also. And if I am going to take this as the center, then also I can draw a circle with any of the radius. So we can say a circle can be drawn with any center and any radius. All right angles are equal to one another. See, all the right angles will be 90 degree only. Whatsoever the lines will be, whatsoever the rays which are forming the angle, it could be any of the ray, but the angle, if it is 90 degree, then they will be equivalent to each other. As just now we have said, equals are if there are two things are there which are equivalent to each other, then they will be equivalent to each other also. That simply means if A is equivalent to B and B is equivalent to C, then we say A is equivalent to C also. So if we have drawn 2 or 3 or 4 right angles, so all the right angles will be equivalent to each other, equivalent to one another. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles. Two right angles means 180 degree. Because one right angle means 90 degree, so two right angles means your 180 degree. Then the two straight lines, if produced, indefinitely meet on that side on which the sum of angles is less than two right angles. That means if we have taken two lines, we have taken, suppose this is one of the line and this is another line, these two are the lines, and we are drawing a straight line falling on these two straight lines. Suppose this is your line AB, this is your CD, and this is your EF. These three are the lines. So if a straight line falling on two straight lines, these two straight lines were there, we have taken one straight line which is falling on these two straight lines. Nowadays we say it to be a transversal. So if the interior angles on the same side of it taken together less than two right angles, from here we can see there are two sides are there. If this is a transversal, this is a straight line which is falling on these two lines, then these are the interior angles on the same side of the transversal. Suppose this is your angle 1, this is your angle 2, this is angle 3 and this is angle 4. So if angle 1 plus angle 2 is less than your 180 degree, over here we can see angle 3 plus angle 4 is greater than your 180 degree. So if we are going to produce these lines AB and CD in this direction, because in this direction your sum of the interior angles on the same side of the transversal is less than 180 degree. So if we are going to produce these two lines in this direction, then they are going to intersect each other. If we will be producing these lines in this direction, so the distance between these two lines will keep on increasing. It is not going to come close to each other. It is not going to intersect each other. So the side where sum of the interior angles on the same side of the transversal is less than your 180 degree, if we are going to produce the lines in that direction, they are going to intersect each other. So if angle is less than your two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of the angles is less than two right angles. The side where sum of the angles, interior angles, is less than two right angles, that means is less than 180 degree. If we are going to produce the lines in that direction, they are going to meet each other. This is your fifth postulate. Now, based on this fifth postulate, they are equivalent version of this fifth postulate also. So, what they are? So, equivalent versions of Euclid's fifth postulate says, if a line EF falls on two lines AB and CD. So, two lines are there, AB and CD are the two lines. And if one of the line falls on it, that is your EF. and the sum of the interior angles on the same side of the transversal is 180 degree. That means this is a transversal. If the sum of the angles on the same side of the transversal, 1 plus 2, or we can say 3 plus 4. On the same side of the transversal, over here it is your angle 1 plus angle 2. On this side it is your angle 3 plus angle 4. If this is equivalent to your 180 degree, if angle 1 plus angle 2 is 180 degree and angle 3 plus angle 4 is your 180 degree, then these two lines will never intersect. In that case, the distance between these two lines will always remain same. In whatsoever the direction we are going to extend these two lines, they will never ever intersect each other. Because see, in this it was said the side where the sum of the angles is less than 180 degree, if we will be producing in that direction, they will be intersecting each other. So if it is equivalent to 180 degree in both the sides, this side of the transversal also the sum of the interior angle is 180 degree, this side of the transversal also the sum of the interior angles is 180 degree. So if the sum of the interior angles is 180 degree, in whatsoever the direction we are going to extend both the two lines, we are going to produce these two lines, they will never ever going to intersect each other. They will be parallel lines. Another is your Playfair's axiom. According to it, for every line L and for every point P, suppose this is a line L, and for every point P not lying on L, that means point P will not lie on this line L. Suppose this is the point P. There exists a unique line passing through P and parallel to L. So if there is a line L and there is a point P which is not lying on this line L, in that case from this point P we can draw a unique line which will be parallel to this L. So from this point we can draw infinitely many lines. Like this, we can draw infinitely many lines, but only one line will be there which will be parallel to this line. So according to your Playfair's axiom, for every line L and for every point P not lying on L, there exists a unique line. This will be the unique line passing through P and parallel to your L. So these are your Euclid's postulates. Now let's understand some of the theorems. That means statements which can be proved using some of the axioms. So first theorem is two distinct lines cannot have more than one point in common. That means if we are going to take any two distinct lines, this is one of the line and if this is one of the line, so they may have maximum of one point in common. If these two lines will be parallel to each other, in that case they won't have any point which will be common for both of them, and if this is not the case, then maximum of one point will be there which will be common for both of them. The second is if L, M, N are lines in the same plane such that L intersects M and N is parallel to M, then L intersects N also. So over here three lines are given to us. One is your L and one is your M and both are intersecting. So suppose this is your L and this is your M. And now N is parallel to M. If there is a line which is parallel to M, suppose this is the line which is parallel to M and this is your line N, then this line N will be intersecting your line L also. This is your second theorem. That means if there are two lines, one is your L and one is your M, these two are the intersecting lines, and if we are going to draw a line N which is parallel to the M, in that case this line L will be intersecting your L. That means N and L will also be your intersecting lines. If L and M are intersecting lines, over here again L, suppose this is L and this is your M. L and M are intersecting lines and L is parallel to P. This L and this P, suppose this is your P, they are parallel to each other. And Q is parallel to M. This is M and suppose this is your Q, which is parallel to your M. In that case, P and Q also intersect. This line P and this line Q will be intersecting each other. If your L and M are intersecting each other, and if we are going to draw a line parallel to L, that is your line P, and if we are going to draw a line parallel to line M, that is Q, then they both P and Q will also intersect each other. The fourth theorem is, if lines AB, AC, AD and AE are parallel to a line L, suppose this is a line L and your a line is there, your A, B, C, D, E. So line AB is parallel to L, AC is parallel to L, AD is parallel to L and AE is parallel to L. In that case, your point A, B, C, D, E will be collinear. These points will be collinear to each other because a line, if there is a line L, so parallel to this line, this is one of the line. If your AB is parallel to L and AC is also parallel to L, in that case, if suppose I am saying this line is your, suppose here, this is your AB. In that case, it will not be parallel to your L because A is common for these two lines, AB also and AC also. Now see, what we learned is, if there is a line L and a point A outside the line which is not on the line, then from this point A we can draw a unique line which will be parallel to your L. So from A point we can draw only one line which will be parallel to your L. Now in AB, AC, AD and AE, A is common, so if they won't be collinear, in that case this condition is not fulfilled. It cannot be said that they will be parallel to your line L, because if there is a point A outside the line L, then from this point A we can draw only one line which will be parallel to the given line L. So that simply means your A, B, C, D, E will be collinear points. So till now, whatsoever we have learned about the geometry of your plane figures was your Euclidean geometry. Now the geometry of the universe we live in is your non-Euclidean geometry. It is not Euclidean geometry because we are not dealing with your plane figures only. So it is basically your spherical geometry. That means lines. It's not your straight. In this, your lines are not straight. Rather, it is parts of your great circles. So nowadays, we are dealing with your non-Euclidean geometry, that is even known as your spherical geometry. And in this, lines are not your straight lines. Rather, we can say the parts of your great circle. The lines are your parts of your great circles. Now, let's see some of the questions from your exercise 5.1. Say question number 4. If a point C lies between 2 points A and B, there are 2 points A and B, in between there is a point C, such that AC is equivalent to BC. AC is equivalent to BC, it is given to us. Then prove that AC is equivalent to half of AB. We have to prove that AC is equivalent to half of AB. Given to us is, what is given? This is your given to us, that AC is equivalent to BC, and it is to prove. We have to prove that AC is equivalent to half of AB. Now in proving, what we will be doing is, first of all we will be writing AC is equivalent to BC, it is given to us. Now if AC is equivalent to BC, if I am going to add AC both the sides, that means we will be doing is AC plus AC is equivalent to BC plus AC. If equals are added in equals, the result whole is even equal. It's your Euclid's axiom only. If equals is added to the equals, your result is even equal. So AC was equivalent to your BC. In this equals, I have added AC equal. That simply means your result or the sum will even be equal. That means this will be equal. If I'll be solving it further, AC plus AC will be your 2 times of AC. It is equivalent to BC plus AC. BC plus AC will be your AB. Right? So AC will become 1 upon 2 times of your AB. And this was to be proved. So hence proved. This is how we can prove it. Now see the question number 5. In question number 4, point C is called a midpoint of the line segment AB. C will be the midpoint of line segment AB. Prove that every line segment has one and only one midpoint. If C point is exactly in between your A and C, then C will be the midpoint of your AB. Now we have to prove that every line segment has one and only one midpoint. That there is only one midpoint. Now over here, what is given to us is AC is equivalent to half of AB. This is according to your question number 4. It is given. Now we have to prove that there is only one point is there on the line which will be bisecting it, which will be dividing it into two halves. Now suppose I am saying, suppose this is your line AB. Over here it is your A, over here it is your B, over here it is C, and over here it is your D. So we are assuming that C is not the midpoint of your AB. Instead of C, D is the point which is the midpoint of your AB. Now, if D is the midpoint of AB, in that case, AD will be equivalent to your half of AB. If D is the midpoint of AB, that simply means AD will be half of your AB. And if something is equivalent to your equals, if there are two things which is equivalent to the equals, then they both are even equals. If there are AC is equivalent to half of AB and AD is even equivalent to half of AB, that simply means your AC will be equivalent to AD. From these two we can interpret that AC will be equivalent to AD, and if AC is equivalent to AD, that simply means C and D are going to coincide, and coincide, that means they are not two different points, they are the same point only. So how it is possible? Because it is contradicting our assumption. Our assumption was that C is not the midpoint, D is the midpoint, so our assumption was wrong. Basically, C and D both are going to coincide. They are not two different points, they are the same point, or we can say that there is only one point which will be dividing the line AB into two equal halves. Then question number 6. In figure 5.10, if AB, just make the figure first. This is your A, this is your D, this is B, this is C. Now, if AC is equivalent to BD, given to us is AC is equivalent to BD, it is given to us. And we have to prove that AB is equivalent to CD. This we need to prove. Now over here given to us is that AC is equivalent to BD, it is given, and we have to prove that AB is equivalent to CD. So whatsoever the given to us, first of all we will take it as AC is equivalent to BD. Now if from AC is equivalent to BD, if I am going to subtract BC from both of them, if from the equals we will be subtracting equals, your remaining will even be equal. So from this I am subtracting BC. So AC minus BC is equivalent to BD minus BC. AC and BD both were equal, and from equals I have subtracted this equals. So your remaining will even be equal. AC minus BC will be your AB, and from BD, if I will be subtracting your BC, it will be your CD, and that was to be proved, so hence proved. It was to be proved and we have proved it, so hence proved. So this is how these type of questions will be solved. This is all from this chapter. Hope it is clear to you what is axioms, what is postulates, what theorems are, and what all the Euclid's axioms, postulates and theorems are. Soon we'll be coming with the more videos on the next chapters, all the other chapters of your class 9 syllabus also. If you have not yet subscribed to my channel, please do subscribe it. Thank you.